Hello and welcome to the 15-minute pre-recorded talk version of my presentation on OpenMosaic, which is a package I've been working on for open source and extensible NEXRAD Mosaic creation and storm object feature extraction in Python. And just start out with a quick shout out to my co-authors who helped with designing the specifications for what we need the software for. And I should probably also mention my institution, Iowa State University right now. Graduate student there. So continuing on, you may ask, why do we need another NEXRAD Mosaic? If you're used to the field of radar meteorology, you know that there's a lot of NEXRAD Mosaic data products already out there. There's MRMS, there's GridRad and GridRad Severe, there's NOWrad, MYRORRS, multi-year reanalysis remotely sent storm in development. So why do we need another one? Why do we need OpenMosaic? And first thing is that it helps to think about this more as a tool. This is really a piece of software for working with and creating these mosaics, not just the data product itself. So it's for cases where these data products don't fit what you need already, or you, for some reason, need to create or roll your own NEXRAD Mosaic. And that second bullet point really sort of lines up what some of those common reasons are. It could be that the frequency of mosaics in those other data products are insufficient. You need higher temporal resolution than what those provide. It could be that the particular one maybe does have the times you need, but it doesn't have the fields that you want, or derived products, various things like azimuthal shear, or various forms of echo classification. Could also be that the historical record period that that data product is available for doesn't have the dates you need for your experiment, for your case study, whatever you need. Or you could also have concerns about accessibility of the archive. Some of these are still under development and limited to release to only one or two institutions, not to the entire research community. And concerns about reproducibility. A lot of these are based off of closed source codes rather than something that's open source, inspectable, and something that you can reproduce completely and easily on your own. So the two projects that came up in the research group here at Iowa State that really motivated the need for this OpenMosaic piece of software. The first project is the NOAA-HWT project here. We're working on probability of wind reports actually being truly severe wind levels using ML methods, machine learning methods, to try to evaluate that. What they want for radar is primarily composite reflectivity in every 15 minutes, sort of 30 minutes and 30 before and after the storm report. 64 kilometer square images centered on the local storm report. The range of study is primarily 2007 to 2018, and also the ability to run it in real time during the hazardous weather testbed. The second project, that one's mine personally, is working on machine learning classification of MCS morphology, or system storm mode. And this I'm hoping to have composite reflectivity, echo classification, and azimuthal shear to help pick out details of stratiform versus convective and various mesocyclone signatures. Here, looking at hourly data, so a little bit more comparable to existing data products, but the need for some of those other fields aren't quite there. And these are larger images, more mesoscale oriented boxes, but still local storm report centered. So with that, what is a grad student to do with that kind of motivating example? Well, develop an Arbit software that can handle the general purpose case. So in OpenMosaic, take the approach of leveraging the existing Python ecosystem. I have a lot of experience with Python development, and this being the Python Symposium makes sense why we're talking about the Pangeo stack, the really predominant collection of powerful software for leveraging cutting-edge tools in the geosciences. So particularly useful here are GeoPandas, dask, and Xarray, but also PyArt. I'll go into a little bit about OpenMosaic and PyArt. It's really an extension of what PyArt has. And the general approach, the philosophy behind OpenMosaic, is to build workflows really fitting those motivating use cases, but as those are developed, create general purpose functions along the way. So you'll see a lot of stuff if you're going through either this rest of this presentation or OpenMosaic's code on GitHub. There's a big focus on storm report centered snapshots at times close to that storm report. Not that you couldn't create just nationwide mosaics at any given time, but that's where a lot of the emphasis is because of the workflows that it was built around. There's also tools for batching across space and time, so rather than just specifying single times, there's utilities for working with storm reports to cluster them across space and time to make efficient work of going through the level 2 archive, and also flexible product types because we have two different experiments that need two different sets of products. So how OpenMosaic relates to PyArt, it directly uses PyArt's level 2 file input to read in the level 2 files that it downloads. Anything with gate filters or pre-processing using directly from PyArt in its framework. Once we get to the gridding routines, of course, PyArt does have some of its own gridding routines, but they weren't quite sufficient for the mosaics that OpenMosaic was designed for. So the key differences from what PyArt has in its Cython-powered routines to what OpenMosaic has in its Cython routines is, one, it implements GridRad's 4D algorithm so that it allows it to include both range and time-dependent weights compared to the different weighting schemes that are built into PyArt. There's discussion about possibly including something like this upstream in PyArt, so stay tuned if you're just a PyArt user and are interested in that kind of range and time-dependent weighting scheme. Also, needed to refactor how PyArt handles multiple radars being combined together onto the same grid, so it can dispatch effectively over dask futures to be parallelized a lot better than just the Python loops that it's implemented as in PyArt right now. Additionally, OpenMosaic adds a bunch of things to make the mosaic creation process go more smoothly. So that includes batch creation tools, GIS operations with GeoPandas. Searching S3 is the current data store that it's built around, not that it couldn't be used with other sources of level 2 data. Additional routines for pre and post gridding calculations on the radar fields, as well as an easy to use gridder class to help organize everything and make it a bit more streamlined. So with that, I want to show a quick demo. Of course, the classic dask dashboard where you can sort of see what these tasks are going on. So if we go right here to that second item in the list, that's our download task. So that's the first thing that is trying to be dispatched out to the dask workers, is to download these level 2 files from S3, Amazon S3. Next up, once those come in, they can be fed into the process NEXRAD, which essentially takes a single radar volume and then, knowing the instrument parameters, it reads it in, determines its coordinates on its native radar spherical coordinates, and then it grids that onto the particular subset of the target domain that you're gridding onto. So it just includes that radar's particular influence on the final output. That creates a sum of values and its weights, which are then saved to be handed off once all of the individual radars volumes in both space and time, so incorporating 4D weights again. Once all of those are together, it's passed off to that third item, the aggregating one, that combines them all together, does some processing to combine any of the fields, as well as the fourth one, post operations, finally combining them all together. So this is a pre-recorded demo video, so I am just going to speed it up here a bit. It doesn't actually go this fast. So once we get all 27 of these sub-collections, it completes. And this example, if we look there, okay, I guess we're not going to look there. That example took around 7 minutes to process what were called 27 sub-batches. That's particular space-time subsets from which we then collect all the individual report outputs, because each report in this example actually has 5 different times that we need to have data both before and after when the report happened. So how efficient is this? Based on some recent tests with just those 64 by 64 kilometer mosaics for the 5 times again, using a 6 dask worker configuration, just default local clusters. On my local workstation, this worked out to about 47 seconds per report, the whole process downloading, gridding, everything. On NCAR Casper, using Casper instead of Cheyenne to make sure there's internet access, that was a bit slower at 72.5, and it was much, much slower in the current test on our local HPC system at Iowa State by approaching an order of magnitude. That is something I'll be working on in the imminent future. Probably by the time we have the lightning talk, that will be worked down. That is my goal, to get that more efficient. But in general, in all of the early tests of this software, it's very I/O and download speed dependent. With that in mind, that really motivates data proximate workflows for this. So that's the other thing I'll be exploring, and feel free to ask me about at the lightning talk session, is how the tests on Amazon EC2 and Azure go, because the hope is that if we can effectively run this where I/O speeds, due to transit distance, essentially, you're grabbing from the same data center, will be simplified, and download speed, both of those, if we cut those way back, hopefully this can get sped up a lot, leveraging the Pangeo stack's ability to run really effectively on the cloud. So that is a goal for OpenMosaic. Comparing the output, you can see sort of side by side, it looks almost identical to GridRad. And that's by design. We're trying to use the same exact algorithm that GridRad does. There are some subtle differences based on filtering that aren't identical and the native grid. OpenMosaic is in this implementation using a native 2 kilometer Lambert conformal grid. GridRad has a latitude longitude grid, so there are some slight differences in regridding. MRMS sample from this same time, of course, shows definite difference. It's a little bit higher resolution of a product and a little bit different sensitivities in values as well. More robust comparisons like this are definitely possible, but had some time constraints trying to get this example produced. So again, time constraints, 2020, kind of the story of a lot of things here. There's a lot left to do with OpenMosaic to get it to the place where I hope it to be, so it can be most effective for the community. Fields beyond reflectivity are implemented, but they're kind of buggy right now. So going to try to work with others to try to improve this, validate this, and try to effectively implement these fields for research use. Also still finalizing the post-processing routines, have those in a variety of scripts, but still need to organize and implement those in this package, as well as some things with optimization and testing for data proximate workflows on various clouds. Finally, right now it's just a GitHub repository with locally installable if you want to run everything and test out yourself. It isn't packaged and ready to go, and there aren't docs, and CI is not implemented either. So all those things are planned to come up here in the near future. So with that, I want to, in the spirit of open source, please come help test this and contribute to this. If you're at all interested in NEXRAD Mosaic creation and are interested on the software side of making these mosaics rather than just using the data products that are out there right now, please come help test and contribute to this. So with addressing features that you'd want to see, if this works with your research problems, or what's missing, various fields, or anything that you need for your particular problem. If you have expertise on derived radar fields, that's a particular issue where I've been running into issues, so I'd love feedback and help with that. And help getting to initial release. If this is something you want to use in your research workflows, it would be great to get some help to get this packaged and actually released. So right there is the link to where the project is on GitHub. And if you have any particular or specific questions or comments for me, my Twitter handle is WX0JT. Feel free to reach out to me there. And thank you for listening along to this recorded talk, and hope to see you at the Lightning Talk Q&A session. Thank you.